In this video, we will review how to use the unit circle and use the unit circle to draw the graph of sine theta and cosine theta. Along the way, we will learn a new unit of measurement for angles called radians. Okay, the first question here, example 1. Example 1 is find the value of sine theta, cosine theta, and tangent theta when you're given this angle theta. Now, I don't know the exact value of theta, but let's say all we know is that if you draw this angle theta on the unit circle, the ray it creates meets the circle, the unit circle, at the coordinate -4/5, 3/5. Now remember, the definition of sine and cosine was that whenever this ray hits the unit circle, your x-coordinate will be called the cosine of theta, and the y-coordinate is called the sine of theta. Along with this, in order to find the value of the tangent, you would need this formula that we learned last time. Tangent theta equals to sine theta divided by cosine theta. Okay, so you'll probably see that the answer is already very straightforward. It's already given to us. Cosine theta is this x-coordinate, so cosine theta is -4/5, and sine theta is the y-coordinate here, so it's 3/5. And then to get the tangent theta, you will need to write down sine over cosine, which is sine theta is 3/5, and cosine theta is -4/5. Okay, this has to be simplified because it's a complex fraction. It's a fraction. It's fractions inside fraction. So you have to use some sort of simplifying. One way to do this will be something a lot of people call keep, change, flip. You keep this, change the division into multiplication, but flip the denominator. But the one I like to do is to actually multiply the same number top and bottom. In this case, I choose to multiply by 5 because 5 will cancel the denominator 5 and immediately give you the answer -3/4. I pulled the negative from here to there because positive divided by negative is negative. Okay, it's pretty easy, right? Now let's try to think of another question. The second question here is example 2 here is find the value of sine theta, cosine theta, tangent theta, but this time only the angle is given and we have to figure out where it is going to hit on the unit circle. Now the effective way to do this will be to think about something called the reference triangle. The reference triangle is a right triangle whose base is on the x-axis and the height connects to the point it hits the unit circle. Okay. Now what is this angle then? This angle is 60 degrees because 180 minus 120 is 60 degrees, and this is 30, so you probably see now that this is the 90, 60, 30 degree special triangle. Now, if this length is 1, because this is the radius of the unit circle, what would be the height and the x-coordinate? So let's think about the following. We had that special triangle before, and that special triangle was 1 here, 2 there, square root of 3. And this was 60 degrees. Okay. We know that since this is 60 and 90, that's also 60 and 90. These two triangles are similar triangles. I should have drawn this bigger because this is supposed to be 2 and that's 1, but figure is not drawn to scale. So how do we make this identical to this triangle here? Well, you can shrink everything by 2. If you divide every side by 2, divide by 2, divide by 2, divide by 2, then this triangle is exactly same as this triangle because the hypotenuse now is matching this number 1. So we know that this length over here is 1/2, and this length is the height. So base length is 1/2, and the height is square root of 3/2. Now what does that mean for the actual coordinate of this point? We have to be a little careful here because you're not moving to the right, you're moving to the left. That means the x-coordinate is negative. You're going half step to the left, so the x-coordinate is not just 1/2, it's negative 1/2. And the height is square root of 3/2. Okay, that's it. So since we have the coordinates, now we can confidently write down that cosine of theta is negative 1/2. Sine of theta is square root of 3/2. And tangent of theta, as before, it's sine over cosine, which is, so tangent theta is square root of 3/2 divided by negative 1/2, and I choose to multiply 2 to top and bottom so they cancel. And then after the cancellation you get negative square root of 3 as the value of the tangent function. Okay, hopefully we'll have some chance to do more of these examples, but what I want to try now is to actually draw the graph of sine and cosine using the unit circle. The previous two questions were given so that you can review the concept of the unit circle and the trigonometric function. Okay, so let's first think about the value of the sine at 0 degrees. Sine 0 degrees. Okay, so what is sine 0 degrees? You're trying to make an angle of 0 with respect to the positive x-axis. So you draw this ray like that. And since they're the same line, the angle between this red line and the black line is 0. So it does make this angle of 0. Now, where does it hit the unit circle? Remember, this is a unit circle, meaning that the radius is 1. So when you get here, the coordinate is 1, 0. Now, can you read the sine value? It's cosine, sine, so sine value is 0. How about sine 90 degrees? Now let's try to go to the 90 degrees. This is 90 degrees with respect to the positive x-axis. And again, you're going up by 1 to meet with the circle. And therefore, the coordinate of this point here is 0, 1. Which means cosine 90 is 0 and sine 90 is 1. Okay, we'll just keep going by multiples of 90 degrees because those are the easiest to figure out when you're working with the unit circle. So the next step will be 180 degrees. 180 degrees is this one. This angle is 180 degrees. So starting from the origin, your ray goes this way. That means you're going left by 1, so this coordinate is negative 1, 0. So cosine 180 is negative 1, whereas sine 180 is 0. Okay, next up, 270 degrees. Think about what this coordinate is. It's 1 this way, negative 1, and it's on the y-axis, so x coordinate is 0, and the y coordinate is negative 1 because you're going 1 down. Okay, so you have sine of 270 degrees equal to negative 1. Okay, and then how about sine of 360 degrees? 360 degrees is a full circle, so you come back to the original line, so you're back to 1, 0, and if you read the value of sine, you get the 0 back again. Okay, using these values, you can create the graph of the sine. So let's try to draw the graph of the sine curve. It's let's say this is 0 degrees, and that's 90 degrees, and that's 180 degrees, 270, and 360. Okay. Sine of 0 is 0, so you have to plot 0, 0, 0, 0. Sine of 90 is 1, so if I say this height is 1, 90, 1 is over here. 180, 0, so again 180, 0. 270, -1, so you're back down here. This is -1 here. The height here is -1. 360, 0, so you're here. Okay. So we know that the graph of sine should be connecting these points. Okay. To help us to imagine the graph a little better, let's do just one more angle. Let's try 30 degrees. So let's try 30 degrees. 30 degrees. And I can use this reference triangle, but let's just say we looked at the table of values that we did last time. So at 30 degrees, we know that sine of 30 degrees is 1/2. So it's like halfway between 1 and 0. So it's right here. Okay. So if I connect these 3 points, so let's write down sine 30 degrees is 1/2. This is something that we figured out last time, not from the unit circle. Okay, so it should be doing this. It's curved that way. Okay. Now, and then if you imagine that you did more angles between these 90, 180, 270, and 360, you will kind of notice that the way it's going to vary, the sine function will vary, will be pretty similar to how it varies here. So just connect these other dots in the same similar manner. So it's going to give you this kind of graph. Okay. So that's the graph of sine theta. So if you drew the graph of y equals to sine theta, with this axis being theta and this axis being y, you're going to get exactly this graph. Now notice that you can actually go beyond 360 degrees. You can go, for example, 450 degrees. So 450 degrees will be going all the way around the circle 360 and then plus 90 degree more. So that will be same as the 9 degrees. This means that the sine function, if you draw it, it's going to repeat itself every 360 degrees because 360 degrees is a full circle. So if you continue to draw this graph, you would get the same kind of shape again and again. Okay. Not only that, you can also do negative angles too. If you have negative 90 degrees, that really means instead of going counterclockwise, as we have done here, we should be going clockwise. So negative 90 degrees means you're going clockwise by 90 degrees from the x, and you can see that negative 90 degrees stop at the same place the 270 degrees is. So the terminology that you use is the following. Negative 90 degrees is coterminal to 270 degrees because they stop at the same point. So coterminal, their terminal point is the same thing. Okay, so if you do this, then you can also draw the graph of the sine function going to the left, and basically all the graphs are just the repetition of what you see from 0 to 360. So knowing the graph of the sine from 0 to 360 is important. If you know this, you can always copy and paste this much to the right and to the left to create the graph of the sine for any angle. You can do the same thing for the cosine, but it's getting pretty boring, so let me just show you the graph for both functions. So here's the graph of sine x and cosine x. This one here, as we just seen, this is the graph of y equals to sine. I have x as this axis, so at y equals to sine x, where x is like 180 degrees, 90 degrees, here's 270 degrees, and 360 degrees, and 0, will give you this graph, this smoothly varying graph. Same thing over here. This is the graph of y equals to cosine of x, where x is 0, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. And of course, these cosine 2, it repeats itself every 360 degrees. So if you were to draw the graph after 360 degrees, it would repeat itself. So it would be like this, and then over here you'll be also going like that. Yeah. Okay. So these are the sines and sine graph and the cosine graph, which you have to memorize. Of course, if you ever get confused which one is which, you can come back to the unit circle and try out what's going on. See, for example, if you want to know the value of the cosine at 90 degrees, you can always go to 90 degrees, draw this ray of 90 degrees, this 90 degrees, and see where it meets. This coordinate is 0, 1. So we know that cosine of 90 degrees is 0 and sine of 90 degrees is 1, exactly as the sine graph and the cosine graph shows over here. Okay, now let's talk about radians. Radians is a new way of measuring angles. Just like when you measure lengths, there are two ways that you measure. You can measure things in meters, and you can measure things in feet. Somehow scientists and mathematicians realized that degrees is not always the best way to measure angles, so they made up a new kind of unit for measuring angles, and that's called radians. Now, you may have wondered why a circle is divided into 360 degrees, not like 100 degrees being the full circle. The reason goes way back to the ancient Sumerians. The Sumerians were very advanced in mathematics, and they used 12-digit system. They counted in dozens and 60s, multiples of 60s. Why? Well, some people think the reason for this is because they had 6 fingers in each hand. But I think the more plausible theory is that the number 12 was considered holy, and it held some religious importance. And the ruling class back then, which were also the religious class, religious priests, made 12 as an essential part of their number system. Nowadays, the reason the day is divided into 24 hours and a year is divided into 12 months is because of the Sumerians. And for the same reasons, the circle is divided into 360s. Okay, anyways, this degree system dividing the circle into 360 numbers is pretty arbitrary, and mathematicians realized that when they tried to do calculus, the degree system for measuring angles makes some equations very messy, and it's very inconvenient. So to make calculus calculations easier, mathematicians made the new system called radians. It's radians. And just like feet is written as ft, if you measure something as radians, you put rad as the unit. This system uses the unit circle to measure angles. All right, here's how it goes. Suppose you have some kind of an angle that you want to measure. Okay. Well, before you would put a protractor over here and read the degrees from that. Now, the way we are going to measure this angle in terms of radians is the following. We are going to put the unit circle over this. So when you put the unit circle over it, you get this ray with this angle that we are trying to measure. Okay. And and that ray is going to hit the unit circle at a certain point. Now the radian system uses the arc length of this arc that's created by the ray and the x-axis as the measurement of this central angle. Okay, to understand what this really means, let's try to measure the 90 degrees in radians. Okay, 90 degrees is right angles in radians. So here's the 90 degrees. The 90 degrees meets the unit circle here, and therefore we need to figure out the arc length of this much. Now, how does this work? Well, the way we calculate this is first realize that the circumference is the diameter times pi. That was the definition of pi when you first learned it, right? Pi is 3.1415 something. And that pi is the number where you multiply to the diameter to get the circumference, right? Now, what's the diameter of this unit circle? Well, because the radius is 1, the diameter is actually 2. This diameter is 2. So the entire circle has the length of 2 pi. That's 2 times pi, that's 2 pi. Okay. And then now look at how much is this arc with respect to the entire thing. It's a quarter of the entire circle, right? So you can say you have to divide 2 pi into 4 equal parts, and if you reduce 2 and 4 as 1 and 2, you get pi over 2. So pi over 2 radians is same as 90 degrees. Okay, so here are two different units, as you can see. Just like when you convert feet to meters, the numbers are completely different. You have two completely different numbers here with different units. Here's the radians, RAD, and here's the degrees denoted by this small circle. Okay, so pi over 2 radians is same as 90 degrees. Okay, perhaps the most important angle in radian system is the 180 degrees. Why is that? Well, because if you have 180 degrees here, you get this ray, and that creates the arc, this arc here, which is half the entire circle. And remember, the entire circle has the circumference 2 pi. So if you divide that by 2, what would you get? You get pi radians. So we just found out that pi radians is equal to 180 degrees. Now this is very convenient for us if you remember. Just memorize this. This is the most important fact. Okay, pi radians is same as 180 degrees. This is very convenient for us because, for example, if you wanted to know what is 60 degrees in radians, just think about it this way. 60 degrees takes the half circle, this pi, into 3 equal parts. 180 divided by 3 gives you 60 degrees. So what is 60 degrees in radians? You take the pi, which is 180 degrees, and divide it into 3 equal parts to get 60 degrees. So 60 degrees is pi over 3 radians. You can do this for other special angles. Let's try that. So the next thing that we should be doing is the 45 degree one. 45 degree angle cuts like this. And if you look at this picture, if you thought of this as a pizza slice, this pizza slice fits on the half of the pizza 4 times, right? 1, 2, 3, and 4, right? So 45 degrees is what you get if you divide 180 degrees by 4. So 45 degrees is pi over 4 radians. Okay. And then finally the 30 degrees. Well, 30 degrees cuts the 90 degrees into 3 equal parts, right? So if you compare it to the 180 degrees, it cuts the 180 degrees into 6 equal parts. So you get 30 degrees equal to 180 divided by 6 radians. Now for other angles, you can make use of these 3 facts. So hopefully by the aid of the graphics that you've just seen, you can easily remember that pi divided by 3 radians is 60 degrees, and pi over 4 radians is 45 degrees, pi over 6 radians is 30 degrees, and we also did pi over 2 radians as the 90 degrees, right? Okay. So for example, if you wanted to convert 210 degrees, ask yourself if 210 is any of the multiple of these things. And yes, 210 degrees is 7 times 30 degrees, right? This is 7 times 30 degrees. And since 30 degrees is pi over 6, you have 7 times pi over 6, which is 7 pi over 6. Let's do some more. How about 135 degrees? This is, it's 3 times 45 degrees, so it's 3 pi over 4. Okay. Now, we used to call 30, 45, and 60 as special angles, but from now on the unit circle, any angle that's a multiple of 30, 45, 60, or 90 will be called special angles. Okay, and if you have those special angles, you can always write it as something pi over 2 or 3 or 4 or 6. Okay, so let's think about all those angles. So I guess the smaller angles are here. The first thing I get after these numbers is 120 degrees. That's twice of 60 degrees, and 60 degrees is 180 divided by 3. So just think about this. 180 divided by 3 is 60. 60 times 2 is 120, so you get this. Okay. And by the way, because radians is so natural, it uses a mathematical object to measure the angle. It's somewhat more natural than the degree system. So when you are measuring angles with radians, we sometimes just don't write RAD at all. If you see some angle without any unit written, then you can pretty much take it as written as radians. Okay, so I'll just omit the RAD from now on. So we have 120, 135. We have over here 3 pi over 4. The next one is 150 degrees, which is 5 times 30 degrees, and 30 degrees is 180 divided by 6. Okay. And then the next is 180 degrees. I told you to memorize this. This is pi radians, the most important one. 210 degrees, we did that over there. It's 7 pi over 6. 225 degrees, that's 5 times pi over 4. 240 degrees, that's 4 times 60 degrees, right? So it's 4 times pi over 3. 270 degrees is 3 times 90 degrees, which is pi over 2. 300 degrees is 5 times 60 degrees, so it's 5 pi over 3. 315 degrees is 7 times 45. That's a little hard to think, but it is. You can check. 7 pi over 4. I guess I'm going a little fast here, but try to take some time to review these numbers. It's very, very important. You want to take the unit circle and start taking those slices of 60s, 30 degree slices, like this. and think about all these special angles. And also you can take the slice of 45 degrees, just like that, and think about these special angles. And for each of these angles, you should try to figure out what they are in terms of degrees and also in terms of radians. That will be very important later on. Okay, so 330 is 11 times pi over 6, because pi over 6 is 30 degrees. 30 times 11 is 330. And then 360 degrees is finally twice of 180, so it's 2 pi. Alright, so these are some numbers that you have to be comfortable with. I don't mean for you to memorize these. Hopefully if you solve a lot of these conversion questions, at some point these angles will be quite natural to you. Okay, now so we found out what the correspondence is between the radians and the degrees for these special angles. What about angles that are not special? Okay, so let's think about that question. Suppose you have 35 degrees and you want it to convert into radians. The way you do this is by multiplying pi over 180 degrees. Okay, pi radians, 180 degrees. Now, as a number, pi over 180 is not 1, but if you include pi radians and 180 degrees, these are same lengths. So if you divide, this is like equal to 1. Yeah. So without the units, it's not 1, but with the units included, it's equal to 1. So if you have 35 degrees, you can say that 35 degrees times 1 is same as before, but instead of writing 1, I'm going to write down pi radians over 180 degrees. And then another nice thing about units is that other than the temperature, Celsius and Fahrenheit, that's a little complicated, but most of the units that we use in physics, you can cancel as if they're things that are multiplied. So you can cancel degree with this degree, and you have 35 pi over 180 as the result, with the radian rad surviving as the unit, right? And then as you can see, if you look at the unit before and unit after, you started with a degree and you ended up with a radian, so you've converted this 35 degrees into the radians. Okay? Now, however, if you can reduce the fraction, you should. So since they're both divisible by 5, 35 is 7 times 5, and 180 is 36 times 5. Okay, so 35 pi over 180 is 7 pi over 36 radians. So that's the answer is 35 degrees is equal to 7 pi over 36 radians. Now, if this argument was too confusing for you, all you have to remember is when you want to convert degrees into radians, you just have to multiply by pi over 180. That's all you have to remember. And if you have a radians into degrees, you just do the opposite. To go from radians to degrees, you multiply by 180 by pi. Okay. So if you had 2 radians and you want to convert this into degrees, you want to multiply by 180 over pi. Now, why does this work? Again, if you think about the units, it's quite natural. If you put rad here, because that's pi radians and 180 is 180 degrees, the radians cancel and what survives is the degrees. So that's how you remember which one to multiply, because it's quite confusing whether you want to multiply by pi over 180 or 180 over pi. Okay, in this case, when you have radians into degrees, you want to multiply 180 over pi because the units cancel and degrees survive. Okay, so you end up with 2 times 180, which is 360, and pi over pi degrees. Okay, so this is a number. Alright, so we learned the radian system of measuring angles. That means we can also draw the graph of y equal to sine x and y equal to cosine x in radian mode. So here is the sine graph again. It's still y equals to sine x. But let's say this time x is measured in radians. It's still the same graph. The graph doesn't change. What changes is the x coordinates. These are no longer 0, 90, 180, 270, and 360. Instead of 180, it's pi. Instead of 90, it's pi over 2. And instead of 360, it's twice of pi, so it's 2 pi. And the midpoint between pi and 2 pi is 3 pi over 2. This is 270 degrees. 90 times pi over 2 is 90 degrees. 90 degrees times 3 is 270 degrees. And this is 0. Okay, so this is how you draw the graph in terms of radians. The maximum value is 1 and the minimum value is -1. Okay, I think the best way to go about drawing the graph of y equals to sine x or cosine x is to actually remember that the period of sine x and cosine x is 2 pi. 2 pi is 360 degrees, but just remember that the period is 2 pi. We say period is 2 pi because these graphs repeat themselves every 2 pi radians. 2 pi radians is the full circle, so every circle it produces the same graph. It produces the same graph before and after. So you have to remember that the period of sine x and cosine x is 2 pi. And once you have 2 pi, then it's quite easy to figure out the other points because this point is half of 2 pi. So 2 pi divided by 2 is equal to pi. And pi divided by 2 is pi over 2. And the midpoint between pi and 2 pi is simply the average. So in the coordinate system, if you wanted to know the coordinate of a midpoint between 2 points, you simply take the average of the two numbers. So here's pi, here's 2 pi. To take the average means you add them up and divide by 2. Pi and 2 pi are like terms, aren't they? So this pi is 1 times pi, 2 times pi, 1 plus 2 is 3, so you get 3 pi over 2. So this point here is 3 pi over 2.